This video supplements the PowerPoint on pH. So we'll take a look at a couple of the questions in real time. I've got our pH toolbox here. These are sort of all of our tools plus the KW. So we might find that coming in handy to solve for things. There's also sometimes more than one way of coming to the answer. So feel free to comment and include your method of coming to the solution. I'm just going to put down one of the many ways that we can get there. So for the first question, we're given a pOH. So a pOH is part of, the logarithmic scale that's showing us the strength of either the H or the OH. In the case of pOH, it's talking about the strength of the OH in the solution. And because we want to find the proton or the H+, so we really want to find this, we should probably convert our pOH into pH. So given what we want, we're going to try to use this formula here. Another approach is to use the pOH to calculate for OH and then use KW to solve for H. So that's an alternative for this question, but let's just try this out. So with a pH of 3.4, and if we add together the value on the pH scale and the value on the pOH scale, they should equal 14. So we're trying to get that value for pH. We'll just subtract 3.4 from both sides. So 10.6 is the value for our pH. We're going to take that then and plug it into the formula here. So we should be able to solve for the concentration of the H+. If we can do 10 to the power of negative 10.6. So I've got my calculator here. Again, every calculator is a little bit different. So try to stick to one. But basically, if you have a phone and you've got sort of your basic calculator, if you tilt it, oftentimes you can get this scientific calculator. So I'm going to do 10. I'll look for the button that looks like this, or maybe you've got a button that looks like that. So I've got 10 to the power of, and on my calculator I press negative 10.6. Some calculators need you to press 10.6 negative. So everyone will just sort of have to figure out for themselves how their instrument's going to work. And so we've got a final concentration of 2.5 times 10 to the negative 11. So very, very, very small. Next question, we'll go back to the HBr from our last video, and we've got a 0.32 molar solution. We want to find the pH of this. So given that we have the concentration of the hydrogen ion, because when hydrogen bromide is in solution, we're going to get that 1-to-1 ratio of hydrogen bromide to hydrogen ions. So we can assume then that the concentration of hydrogen ions is 0.32 moles per liter. So we'll use this here in our equation, the top one, to calculate for pH. So there's not a whole lot of steps really to be showing other than this. So you want to, show what number did you put in, but the rest it's all fancy footwork here on your calculator. So negative log 0.32. You know, whether you need to close the brackets or not. Now this, when we see a pH of 0.49, this is a very, very strong acid. Very, very strong acid. In the next case, we're looking at barium hydroxide. So now that guy, when it is in solution, will look like this. So it will dissociate into the barium ion and the hydroxide ion, but there's going to be two. So it's a 1-to-2 ratio. So for every one particle of barium hydroxide, we actually double our hydroxide output. So you could take this 0.8 moles per liter and double it. So times that by 2. So we know that we've got twice as much of the hydroxide. We're trying to find the pH, and you'll notice that pH and hydroxide concentration, they do not link up. So one way to do this is to calculate for, like, put this OH in here and calculate out the POH, and then, you know, use this sort of wild card to transfer it. Or, as we're going to do, we're going to use the KW formula. So I'll put my value for OH in here and calculate for H. Either way works. So 1.0 times 10 to the negative 14. That's always our value for KW. The H plus is the unknown. Why am I even going for that? So that I can get pH out. I want to use this equation, but I don't have that value yet. So we'll put in 1.6 here. And we'll solve for X. So instead of multiplying, we'll do divide. We'll do that on both sides. Again, this is some pretty fancy footwork on your calculator. This is where brackets are really going to be handy, especially as you're looking at having the scientific notation on top. Here it's really important to make sure that you've got a double bracket. So the first bracket closes off the negative 14. The second bracket closes off the 1 times 10 to the power negative 14. And now I'm going to divide by 1.6. So I get 6.25 times 10 to the negative 15. And this is H plus. This guy now is going to be placed inside of our pH formula. And again, it's a little bit of fancy footwork here on the calculator. Negative log. My calculator gives us that bracket already. You might have to put it in. 6.25 times 10 to the power of negative 15. Oops. Close the bracket. And again, close the bracket. Whoa. The more you do these, the easier you'll go with that. And so here we see a pH value of 14.